Hi, I'm Paul. We are doing Leetcode must-know interview questions. And today's challenge is called triangle. Given a triangle array, this is not going to make sense until you see an example of it, but given a triangle array, return the minimum path sum from top to bottom. For each step, actually, let me scoot this up a little bit. You can kind of see it. Yeah, there it is. So the input comes in like this. It's a list of lists of integers. So, for example, the list here is a list of 2, the next list is 3, 4, the next list is 6, 5, 7, the next list is 4, 1, 8, 3. And that means that the triangle looks like this. Whoops. Come on. Start here. Triangle looks like that. Just stack each list on top of the next one. Okay. Let's see. For each step, you may move to an adjacent number of the row below. More formally, if you are on index I on the current row, you can move to either index I or index I plus 1 on the next row. Now, the minimum path sum from top to bottom in this one, you can go from 2 to 3 to 5 to 1, and it's a total of 11. In case you're thinking, well, I mean, all we have to do is just take the minimum element from each row. But that's not really right because, I mean, it works in this case, but let's say in the bottom row, we swap the 3 and the 1. Okay, so now there's no way to get from the 5 to the 1. So the minimum path changes. Constraints. The triangle length 200. So there may be as many as 200 rows in the maybe as many as 200 rows in the triangle. There'll be at least one. The first row has a length of 1, and it increases 1 each time. Each subsequent row increases by 1. The length increases by 1. Numbers in the triangle could be negative, could be positive. It goes from negative 10,000 to positive 10,000. Could you do this using only O of n extra space, where n is the number of rows in the triangle? Yes, I think we could actually do better than that. I mean, I think O of n extra space. See, we've moved into the actually the final category of must-know interview questions, and these are the 2-dimensional dynamic programming. There's several of these. And yeah, I mean, let's take a look at this. Let's say, actually, let me draw a DP array here. I'm going to pause this and just draw a DP array. All right, so let's start with this. Now, the question is asking. The question asks for a minimum path from top to bottom, but, you know, it's really the same as a minimum path from the bottom to the top. And in fact, that's a better way to do it because you can tell with each row based on the row underneath it, what the minimum path is going to be. But you have to start at the bottom. So here's our DP array. And we just started out with a size equal to the number of rows, and we initialize it with the bottom row. Now, we are going to, for each element of the second to the bottom row, we are going to see the two numbers adjacent to that number. We're going to do an addition, and we're going to take the minimum number and put it in the array. So wait. No, that's right. Yeah. So 4 and 1 will match up with 6. So we have a choice of either 10 or 7. And the minimum there is 7. So we'll put the 7 in here. All right. The next number in that row is 5. We have a choice of 1 or 8. To add to that, we're going to add the 1, and that gives us 6. All right, so we'll put a 6 in there. 7, we can add 8 or 3. Let's add 3, and we'll get 10. All right. And we're not really interested in this number anymore. All right, let's go up to the second row, the row with the 3 and the 4. Now, we can add 3 to either 6 or 7. And what we want to add it to is the 6, and that'll give us a 9. And then we have a 4, and we can add, I'm sorry, wait a minute. Whoa. Yeah, that's right. And then we have a 4, and we can add the 4 to either 6 or 10. So we'll add it to the 6, and that'll give us 10 here. All right. We don't really care about this number anymore. Now we're at the top row with the 2, and we're going to add 2 to the minimum that we still have left in the array, and that is 9. So 2 plus 9 equals 11. All right. But this is supposed to be a 2D problem, and that's really just a 1D solution. So there's there is a 2D solution where we can omit the process of creating our own DP array and just use the list of lists to store our intermediate computations. So let's see. Let's see if I want to sketch that out or just implement it. All right, so let's say we have the triangle like this. We can keep the intermediate results in the existing list of lists. Other than that, it operates really the same way, which is we're going to go here with 6. Now, what do we want that number to be? You want to add the 4, or you want to add the 1? Well, of course, we want to add the 1. So the 6 becomes 7. The 5 becomes 6. and the 7 becomes 10. All right, up to the next row. The 3 is going to become 9. And the 4 is going to become 10. Okay. And now the top row, the 2 is going to become 11, which is the answer. So the answer always winds up at the top this way. All right, so let's look at an implementation. It's really just a nested, it's really just a nested loop. We're processing a list of lists. Essentially, it's a 2D array. I mean, it's it's a list of lists. So let's do for int I equals. We're going bottom up here, so we're going to start at triangle dot size minus 2. How does that work? Well, the example we looked at, it had 4 rows. So triangle size is 4. 4 minus 2 is 2. And 2 is the index of the second to the last row. So that's what we're trying to get here, is the index of the second to the last row. That's where we're going to start. I greater than or equal to 0, I minus minus. And I'll be that for int j equals 0, j less than or equal to I, j plus plus. All right, let's think about this a little bit. All right, so we would be starting out with the bottom row, and let's say triangle get I. So that gets us the second to the bottom list. And what we want to set that to is we want to set, this will be the index. So we will set each item in turn to triangle.get I. That again is going to get the second to the bottom row. We are going to get the current value of the index j, and we're going to add this is gonna overflow everything. Let's I don't know. Yeah, why does it keep doing that? Don't keep showing me that. I'm just trying to get where is the why can't I put the cursor in here? I think what I want to do is this. Triangle get set plus math dot min. This is still going to be too long. Let me scoot that over a little. Math.min. Math.min of triangle dot get. Now we want to get the row underneath this row. So that would be I plus 1. And we want to get the index j. What does that match up with? Okay, math min. So actually, I want to do that. And do this. Triangle go, and this would be j plus 1, right? And then I think we can close all of those, right? That closes the set. Okay. So what is that going to do? All right, we're going to come through here, we're going to start with the second row from the bottom. For each element in that row, we are going to set it to whatever is in there plus the minimum of what you could call its two adjacent elements below. For example, first time through j is going to be 0, and we're on row 3. I can probably scoot this over so we can see the triangle. Okay, so the first element that we would hit is this 6, and now what we want to add to it is either the 4 or the 1. That is the row 1 index down. We're still going to use index 0. We're also going to use index 1. So that's index j. It's index j plus 1. Okay. And that's it. We're going to loop through the whole thing that way. And when we're done, we're going to return triangle dot get 0 dot get 0, which is the element at the top of the array. So we propagated the minimum sum path to the top of the array. All right, let's try it. What? I think I forgot to close the, what did I forget to close? Wait. That's on line 12. All right. What does that match with? That matches with, I didn't close the for loops, right? Okay, so that's got to be there. This has got to be here. And then this is going to match with what? A public, okay, and then that, okay, that should be fine. So that's accepted. Let's run, or I'm sorry, let's submit. Okay. All right, so that, whoa. Oh, that's the memory? Why is the memory way out there? And you know what? I don't think that is the memory. That's the time. The memory should be better because it said, can you do it with O of n? I think this is O of 1. I mean, let's confirm, but yeah. Okay, so it's a 2D. It's a 2D dynamic programming, and please feel free to like, subscribe, comment, and see you next time.